All right, what's going on, everybody? Today we're going to be talking about proving lines that are parallel. So yesterday we talked about proving that angles are congruent based on parallel lines, but now we're going to go the reverse. Now we're going to see, we're going to prove that lines are parallel based on certain angles being congruent. Okay, so this first one that we have says if two lines in a plane are cut by a transversal, and we're talking about corresponding angles are congruent, then their lines are going to be parallel. Okay, so that means if we have corresponding angles, okay, then their lines that they are corresponding with are going to be parallel. So right here, our abbreviation's already done for us, which is perfect. If corresponding angles are congruent, then those lines are going to be parallel. Okay, and that's how we're gonna write it every time, just like this. This is how you have to write it on your test, okay, and on your quiz, so make sure you pay attention to this. Okay, now over here we have our example over here. Okay, so we're gonna have to come up with some examples based on these lines. Okay, so really what we're trying to prove is that M and N are parallel. Okay, so with corresponding angles, we can say if angle 2, okay, right here is corresponding to angle 6, then M is parallel to N. Okay, now this is pretty much how you would write it out every time, like on your test, on your quiz. Okay, so make sure you're aware of that. All right, okay. And then from here, you can also say, like, you could use angle 4 and angle 8. Okay, you could use angle 1 and angle 5. You could use angle 3 and angle 7. Okay, whatever you wanted to use, really. Okay, you could use any of those. Just make sure you'd write them just like this, though. If angle 2 is corresponding to angle 6, then M is parallel to N, just like that. Okay, now it's the same thing for this next one here. Okay, so for this next one, we have if two lines in a plane are cut by a transversal, and now we're talking about alternate exterior angles are congruent, then the two lines are going to be parallel. Okay, so our abbreviation for that is right here. If alternate exterior angles are congruent, then lines are parallel. Okay, so now looking over here at our example, I don't know why this got cut off. This really should be a line right here. Okay, looking at this example, if we're talking about alternate exteriors, so remember, it's going to be, if these are our two parallel lines that we're trying to prove, then this would be in between those. So we want to talk about these four out here, these four numbers. Okay, so if we want to start with angle 1, we could say if angle 1 is, or if angle 1 and, and angle 8 are alternate exterior angles, then M is parallel to N. Okay, you could also say, so we just did 1 and 8, you could also do angle 2 and angle 7 since those are both outside. Okay, so that one doesn't matter there. Okay, jumping down here, the next one. If two lines in a plane are cut by a transversal and alternate interior angles are congruent, then the two lines are parallel. Okay, so if alternate interior, if two lines in a plane are cut by a transversal and alternate interior angles are congruent, then those two lines are parallel. So this is our abbreviation. If alternate interior angles congruent, then lines are parallel. Okay, so right here, talking about examples, remember we're talking about interior, so we're really only dealing with these four right here. Okay, so we could say if, now here's another way that you can write it. Okay, it's totally up to you. You can write it like this. If you can write it just like we did above here. So if angle 1 and angle 2 are alternate exterior, then those lines will be congruent or parallel. You can also write like this. If angle 3 is congruent to angle 6, then M is parallel to N. So you can do it really either way you want. Okay, this is usually the way people like to do it because it's easier. Okay, it's just easier to write, it's faster. It's just It's just easier for you, okay? And then instead of angle 3 and angle 6, you could have also used angle 4 is congruent to angle 5, okay? But any of those ways you can write it. All right, and then our last one here, okay, talking about if two lines are cut by a transversal and a pair of angles, this should say are, not is, are supplementary. Then the lines are going to be parallel. Okay, so if two lines in a plane are cut by a transversal and a pair of angles are supplementary, then the lines are parallel. Okay, so we're talking about same side interior here. Okay, if same side interior angles are supplementary, then the lines are going to be parallel. So again, remember, we're talking about same side interior, so we're talking about right in here. So we can say if measure of angle 3 plus the measure of angle 5, okay, because right here, equal 180, then the lines are parallel. Okay, you could also say, you could also use 4 and 6, so you could also use if the measure of angle 4 and, so this is a different way to write it, measure of angle 6 are supplementary, then M is parallel to N. Okay, so there's really two different ways you can write them there. Doesn't matter to me which way you want to write it. Either one will do. Okay, but those are really the 4 kind of theorems that we're going to go over today, and that's kind of the only 4 that you're going to use to prove that lines are parallel. Okay, so make sure that those are the only ones you're using. Okay, on this next page, we're going to kind of dive into some examples here. Okay, talking about example number 1, find x and the measure of angle RSU so that M is parallel to N. So it's not telling us that they are parallel, but we are kind of like assuming they are. Okay, that's the only way that we're going to be able to kind of solve these. Okay, so if we are assuming that these two are parallel, okay, it's talking about this angle here and this angle right here. Okay, we can say that these are corresponding angles, which means they have to be congruent. So that means that we can set those equal to each other. So we can do 8x plus 4 equals 9x minus 11. Okay, just like this. All right, go ahead and solve for x. So we'll go ahead and subtract 8x on both sides. Okay, so I get 4 equals x minus 11. Go ahead and add 11 to both sides. So really I get x equals 15. Okay, notice I just switched those around there. Okay, and then it says find the measure of angle RSU. So right here, RSU. Okay, so we're just trying to find this angle right here. So all we're going to do is substitute in x. Okay, so 8 times 15 and then plus 4. Okay, 8 times 15 plus 4 is going to give us the measure of angle RSU to equal 124 degrees. Okay, so these are our 2 answers that we need right there. All right, moving on here, down here to 2, 1, 2, and 3. Okay, which lines or segments are parallel? Okay, justify your answer. Okay, so we need to kind of decide which ones of these start with number 1. Okay, which lines are going to be parallel. Now, the easiest way to do this is to look to see which line or which 3 lines that both of these arcs are touching. Okay, so we can see that they're both touching T here. Okay, and then one of them's touching D and one of them's touching E. So that means we're trying to deal with lines D and E. Okay, we don't care about S. Notice how these arcs aren't touching S at all. Okay, it has nothing to do with S, so we don't really care about S. Okay, all we care about is D, E, and T. Now you should notice D and E appear to be parallel. So really we're hoping that those are going to be the ones that are parallel. T is going to really be our transversal. Okay, so we are going to say that D is parallel to E, okay, because, and then we got to see what the relationship here is. Okay, so notice how they're both on the top of this transversal and both on the right side of this parallel line. Okay, so we can say D is parallel to E because of the corresponding angle postulate. Okay, or if you guys want to, you can write cap. Okay, that's fine with me. Okay, so we can say that right there. Same thing for number 2. Okay, we kind of want to see which line both ones are touching. Okay, so they're both touching A right here. Okay, and then we got to see which one each one of them's touching. So this one's touching AB and this one's touching DC. Don't just say A and don't just say B because we don't know which one you're talking about. Okay, so we know we're going to try to prove that AB is parallel to DC. Okay, but then we got to figure out why. Okay, if we notice, this is our transversal right here. These are our two parallel lines. So these are in between our two parallel lines and on the opposite sides of line AD or our transversal. So it's going to be alternate interior angles. All right, and then number 3, okay, last one here for this one. They're both touching O, and then we're talking about RP and SQ, okay? NT is not in it. We don't care about that one. So we're going to say that RP is parallel to SQ, and then we got to figure out why, okay? In between here, there's nothing, so we know it's going to be exterior, and they're on opposite sides of this transversal, okay? So we know it's going to be alternate exterior angles, okay? We know that's going to be Y. All right, moving on here to the next one, next 3. Determine the value of X for which R is parallel to S, then find the measure of each labeled angle. Okay, so we're saying R is parallel to S. Okay, so right here, this is our transversal. These are the two parallel lines. So these are on opposite sides of our transversal, and they are on the outside of the parallel line, so it's going to be alternate exterior. So alternate exterior tells us they're congruent, so we can do 2x plus 6 equals 42. Subtract 6 on both sides, so we get 2x equals 36 divided by 2. X is going to equal, make sure this is on the camera, X is going to equal 18. Okay, and then it says, then find the measure of each labeled angle. So we actually have to find this measure right here. Okay, but because it's alternate exterior, we already know that this angle is going to be 42. So we know it's going to be 42 degrees. I'm okay if you guys just write that. Okay, that's good. Okay, here, R and S again are parallel. We have our transversal right here. So that means this time they're on the same side of this transversal, and then they're both inside of these two parallel lines. They're in between them. Okay, so this is going to be same side interior, which means that they are supplementary. So if we do 98 plus 3x minus 17, set it equal to 180. Now we have to solve for x. So I'm going to go ahead and combine my two things here. So we get 3x plus 81 equals 180. Go ahead and subtract 81 on both sides. So we get 3x equals 99 divided by 3. And then finally, I'm going to get x equals 33. Okay, that's going to be my final answer there. Okay, and then for our last one over here, again, okay, we notice that R and S, they're in between there, and they're on the same side of this transversal. So again, we have same side interior. So what's going to happen? Again, same thing, 2x plus 20 plus 6x plus 24 equals 180. Okay, go ahead and combine our like terms on this side. So we get 8x plus 44 equals 180. Subtract 44 on both sides. We get 8x equals 136. Divided by 8 on both sides, we get x equals 17. Okay, and then from here, this one we actually need to figure out what these are. Actually, we need to figure out what this one is too over here. Sorry guys, I forgot about that. So when we plug in 33 here, okay, we end up getting that that angle there is 82 degrees. Okay, these two angles, when we plug in x to here, we end up getting that this one is going to be 54 degrees. Ooh, not 540. Okay, 54 degrees. And then this one right here is going to be 126 degrees. Okay, so both of those. All right, last page here. Okay, we have two proofs to go over, which won't be bad, I promise. Okay, they'll be all right. Okay, looking at this. Let's see, how do I zoom out here? Okay, looking at this right here. Okay, we're going to notice. Okay, it tells us E is parallel to F and angle 1 is congruent to angle 3. Now here, this should be 2, this should be 3. We're talking about this angle, and this angle right here. Okay, those are the ones we care about. Okay, you guys are probably going to have to write that down on your paper. Okay, we're trying to prove that G is parallel to H. Okay, so the first thing we need to do is given. That's the easy one. E is parallel to F. And then we can put this all in one step. Angle 1 is congruent to angle 3. That's given. Okay, the second step here. Okay, now you can kind of play around with this and kind of see how you want to go, but we want to go from one of these two numbers up here. So I'm just going to go from angle 1. So I can say angle 1 is congruent to angle 2. Okay, and the reason being, we can say if hang on, sorry, E is parallel to F, then the corresponding angles are congruent. Okay, so it tells us E is parallel to F, so we can say that. Okay, so we've got those. Okay, now we can say, because up here it says angle 1 is congruent to angle 3. Okay, it tells us that. We just said angle 1 is congruent to angle 2. So 1 is congruent to 3, 1 is congruent to 2. Then that means, okay, that angle 2 has to be congruent to angle 3. That is because of our transitive property. I'm sure you guys guessed that. Okay, now some of you might have said, well, then I can say that angle 2 is congruent to angle 3. Now you can't say that because we're trying to prove that G is parallel to H. Okay, these two angles are on G and H. So if you said that angle 2 is congruent to angle 3, then you would already be assuming that they're parallel to that G and H are parallel, and you cannot do that. Okay, you can't do that. So you have to say that they're transitive, and then, okay, because they're parallel, because you proved that they're parallel, then you can say G is parallel to H, okay, because if alternate interior angles are congruent, then the lines are parallel. Okay, so just like that. Okay, and then the last proof down here, example 5, given A is parallel to B, angle 6 is congruent to angle 11. Okay, that's our given right there. Okay, step 2, okay, this is angle 6 here, 11's here, 7's here. Okay, we have to prove that C is parallel to D. Okay, so again, we want to start with either 6 or 11. I'm going to start with 6. Okay, I'm going to say angle 6 and angle 7 are supplementary. Okay, so we know A and B, right? Okay, those are the parallel ones. So if A is parallel to B, then same side interior angles are supplementary. Okay, and then I'm going to go from 7 to 11. Oh, sorry, that should be 3. Okay, 3. Now I'm going to go from 7 to 11, so I'm going to say angle 7 and angle 11 are supplementary.